Welcome back, viewers. So this video will be a continuation of the last video on determinants. The last video we talked about how to find the determinant of a 1 by 1 matrix, a 2 by 2 matrix, and a 3 by 3 matrix using Saro's rule. But today we're going to talk about a method we can use to find the determinant of any n by n matrix. It can work for 3 by 3, it can work for 4 by 4, it can work for 100 by 100. But before we go into that, we need to discuss two terminologies here called the minor and cofactor. So we assume that A is an n by n matrix, so A is a square matrix. Then what do we mean by the minor, Mij? Here I represents the number of rows and J represents the number of columns. So Mij of the element Aij is what? Is the determinant of the matrix obtained by deleting the ith row and what? And jth column of what? Of A. So this is what it's saying. Let's say you have a 3 by 3 matrix. You have A11, A12, A13, A21, A22, A23, A31, A32, and A33. So what is A33? This means the element in the third row, a third column, right? While A12 means the element in the first row, second column. So if you want to find Mij, so for example, if I want to find M12, so it means M12 is what? Is the minor of which element? You want to find the minor of this element. So you're looking for the minor of A12. And by definition, it says what is the determinant. So minor is actually a determinant, but is the determinant of the matrix obtained by deleting the ith row and the jth column. So since you are looking for M12, so it means you have to delete the first row, right? And what? You delete the second column. So what is left? So you are going to now take the determinant. Remember, this means determinant of whatever is left. What is left is this one. A21 is left. Then what? A31. Then here we have this and this. A23 and A33. And you can see this is what? This is a 2 by 2 2 by 2 matrix. So you are taking the determinant, but this is determinant of a 2 by 2 matrix. We discussed in our last video. So this will just be multiplying this by this. So this is A21 times A33 minus A31 times what? A23. Is that okay? So if I want to find, let's say you want to find M13. So what is M23? M23 means you're going to delete the second row and delete what? The third column. So you are going to delete the second row, third column. So it means you're going to delete what? Second row, third column. Then it will now be the determinant of whatever is left, which will be A11, A12, and what? A31 and A12. So this is what we mean by minor. And this is just going to be what? A11, A12 minus A31. No, this should be A22 then. No, what is here? This is A32. Yes. So A11, A32 minus A31, A12. Okay. All right. So this is 32 here. Now this is for minor. Then we also have another one which we call cofactor. What is cofactor? Cij. Cij is just given by this formula. So Cij is minus 1 to power I plus j multiplied by Mij. So if we are looking for, let's say, C12, is just going to be minus 1 to power what? I is what? 1. So you have 1 plus 2, which is j, times what? M12. So this is minus 1 to power 3 is going to be minus. So you have minus M12. So C12 is minus M12. Already we know what is M12, which is just this value here, right? So let's take a particular, but for example, if you need, let's say C23, what is C23? C23 is going to be minus 1 to power what? To power 5 of what? M23. And we already know what is M23, right? So you have to check. Sometimes the power is going to be even, sometimes it's going to be what? It's going to be odd. So for example, if you are asked to find C11, what is C11? It's going to be minus 1 to power what? 1 plus 1 M11. So minus 1 to an even number is just going to be 1. So it's going to be positive. So it means that C11 is just going to be M11, right? Because minus 1 to power 2, it's 1. All right, so let's take particular examples and let's work from there. Now look at example 5. Example 5, it has a matrix. We have a matrix. So we want to find M32, C23. And here we said, what is the cofactor of the element in the first row, third column? So this is like saying you want to find C1 what 3, right? Because first in the first row, third column. So now let's start with M32. To find M32, which is this, all we need to do is what? Is just go to, we go where? We go to the matrix and look for the elements in the third row and what? You cover the third row and second column. So this is going to close, we're going to close here and close here. So that's what we mean by deletes here, this word deletes, right? So what is left now, we take the determinant, which will be a 2 by 2. So you have 2 minus 1, then 3 and what? I think 0, right? Yes, then from here, what is this determinant? This determinant is nothing but 2 times 0 minus what? It's going to be minus 1 times 3. So this will be 0 plus 3 because we have minus minus here. So this is just going to be 3, right? And we're done. Now we find C23. What is C23? Based on definition, is just minus 1 to power 2 plus 3. Then what? M23. Is it? Okay. So we know that this is going to be what? Minus 1 to power 5 is just minus. So it's just going to be minus M23. So take note when the power is even and when the power is odd, right? Okay. So now this minus will have a minus here. Then here will be M23 will be the determinant when we delete what? The second row and third column. So we just need to delete the second row. So this is the second row. So this is actually second row and third column. Then what is remaining will be the determinant of what? We'll have a 2 by 2 matrix, which is what? Which is just 2, 3, 2, and what? And 1, right? Okay. So this is going to be, but we have a minus outside. So this will be 2 times 1, which is 2 times 1, minus 3 times 2, or 2 times 3. So this is minus, and this is 2 minus 6. So this is the same thing as what? This will be minus minus 4. So this is just 4. All right. Then finally, it says here we want to find the cofactor of the element in the first row and what? and third column. And what does that mean? That means C13. So C13 also is 1 minus 1, 1 plus 3, and what? M13. So what is M13? But you can see that minus 1 to power 4 is 1. So this will just be 1. So this will just be M13. And what is M13? Means you delete which row? We delete the first row and third column. And once we do that, we are left with just the determinant of what? Of 3, 4, 2, and 1. And this is nothing but 3 times 1 minus what? 2 times 4. And this will give us 3 minus 8, which is minus 5. All right, so this is how to find minor and cofactors. Now, why do we need minors and cofactor? Is so that we can find the determinant of any n by n matrix. Please follow me carefully. Here, it says if A is an n by n matrix, n could be any size, could be 3 greater than 3, it's fine. We can find the determinant of a matrix by multiplying what? By multiplying each element of the first row by its cofactor, then adding the result. Actually, it doesn't have to be the first row. You can use any row. You can use any column. Any row, any column you like, you can use it. But here, let's assume you want to use the first row. So it means you take the first row, you multiply by its cofactor, you take A12 multiply by its cofactor, you take up to the last one, multiply by its cofactor. Now, here you don't have to use the first row. You can use any row, you can use any what? You can use any column. You can use any row, any column. So this is just a particular case. So let's see. So let's revisit this example here. Now, if you look at example 6, you said evaluate the following determinant. If you look at this matrix carefully, we have done this matrix in example 3. Where we use the Sarus rule for this one. And the determinant we got, if you check the last video, you will see that we got the determinant to be 1, where we remember the Sarus rule, where you have to copy, you repeat this 2, then you draw the diagonal, right? But now we're going to use different method to solve this one. We're going to use this particular method here. Now, so how does this method work? Here, we're going to take, just like I'm going to do it in maybe 2 ways, so please watch. Based on this, what I have here, what does it say? It says take the first elements, take the first row, right? And multiply by its cofactor. So now I will go, what is the first element here? Is minus 2. So you take minus 2, you multiply by what? Its cofactor, which is C11. Then plus, which element is here? 5. You multiply by its element, which is what? Its cofactor is going to be C12. Then plus 4 multiplied by its cofactor, which is what? C13. So here we are using what? We are using the first row based on this information. Okay, so how does this work? Now, this is minus 2, right? This is C11, which is cofactor. I can change it to minor by using the formula minus 1. This will be minus 1 plus 1. Then here I'll have M11, right? So here also it becomes 5. This is minus 1 to power 1 plus 2. Then here becomes M12. So we have moved now from cofactor to minor. Then plus 4. This also will be times minus 1 to power what? 4. Yeah, 4, or I said 1 plus 3, right? Then M13. Now, minus 1 to power 2 is just going to be 1. So I still have minus 2 M11. Here is going to be minus 1 to power 3, so it's negative. That negative will make this to become negative. So you have minus 5 m12. Then this is minus 1 to power 4, which is going to be 1. So you have plus what? 4 m13. All right. So now this is minus 2. What is m11? M11 is going to be the what? The determinant of what is left. M11 means I need to delete the first row and what? First column. So yeah, first column, yes, first row, first column deleted. So we'll be left with what? 1201 minus 5 m12. M12 means I will delete the first row, right? And what? Second column. So here we'll have 3, 2, 3, what? 1. Then plus 4. Then now we have to delete what? M13 means delete the first row and third column. So we are left with 3, 1, 3, 0. Okay. All right. Now, very important here. Here, don't multiply. Don't take this minus 2 inside because this is not a matrix. This is a determinant. Also, this 5 cannot go inside. So you are not. This is not a scalar multiplying by a matrix. This is a determinant. So just leave it the way it is. This is minus 2. Then here, find the determinant here. 1 times 1, this will be 1 minus 0 times 2, which is 0, right? Then minus 5, put a bracket. Here you have, you can use just a bracket here. So here we can use 3 times 1, which is 3, minus 3 times 2, which is 6. Then plus, here is 4. So you have 3 times 0, which is 0, minus 3 times 1, which is 3. So what do we have here? Here we'll just have minus 2 times 1, which is minus 2. Here will be minus 5 times what? Here it's minus 3. Then plus, there should be 4 and what? 4 times minus 3, right? Okay, so let's see what this will be. So this is minus 2 plus, this is going to be plus 15, right? And this is going to be minus what? Minus 12. So you see that this is nothing but 15 minus 14 because minus 2 minus 12 is minus 14. And you can see that the answer is 1. So this is how to find the determinant. So you can say the determinant of A. So which is the same thing using the Saros method. But there is an easier way to solve this one. Now, you can see that here we expanded using what? Using the first row. But just like I said, you don't have to use the first row. The easiest thing to do is you look at the rows or the column where you have 0. And in any entry, in any row or column where you have much 0, try to use that one. Try to use that row or that column. So for example, here you can see in row 3, you have 0, right? And here in what? In either row 3 or what? Column what? Column 2. So now let's try to use row 3 and see what will happen. If I want to use row 3, so here we are using row 3. Here we use row what? Row 1. If you are using row 3, so take this element, which is 3, you are going to multiply by C what? The position of this element is what? 3, 3, because it's in the third row, sorry, not 3, 3, but C, 3, 1. Yeah, third row, first column. Then plus, you go here now. Remember, you are going by row. So this will be 0 times, what is the position of this element? This is third row, second column. Plus, now 1 times, what is the position of this one? The position of this is third row, third column. Now you can see these we are multiplying by 0, so this automatically goes. So it makes life easy. So we just have these two elements to work with. So now this will be 3. We go, this is cofactor, we go to minor. So this is minus 1 to power 4. Then what? M31 plus, this is 1. This is going to be minus 1 to power 6. M what? 3. So this is minus 1 to power 4. So you just have 3 times M31 plus, this also is even. So we'll just have M33, right? So now this will be 3. Then you take the determinant. What is M31? M31 is this one. This is M31. So M31 means you delete. So you delete the what? The third row and the first column, right? So what is left now is what? 5, 4, 1, 2. Then plus. Now M33 means you delete the third row and what? Third column. So you are left with minus 2, 5, 3, and what? 3 and 1. So now this will become 3 into, so determinant, don't take this 3 inside as I said earlier. This is not a matrix. So 5 times 2 will be 10 minus what? Minus 1 times 4, which is 4. Then plus, here will be minus 2 minus what? Minus 15. So this is 3 multiplied by what? By 6 plus, inside there is just minus 17. So what is 3 times 8? 3 times 6 is 18. And this is going to be minus 17. So you can see it's equals to 1, which is the same thing. So any row, you can use any row, you can use any column. You will still be fine. You get the same thing. Now let's solve this one, the B part. You can see this one is what? It's a little bit big. You have 4 by 4. So we're still going to do the same. But if you look at that matrix, 4 by 4, let me write the matrix here, B. This is the matrix. So I can scroll. Minus 2, is it 1? 0, 1. Then 0, minus 2, 1, and what? 4. Minus 3, 1, 0, 2, 1, 0, minus 2, and what? And 1. All right, so this is it. We want to find what? The determinant. This is a 4 by 4 matrix. So how do we do this one? Now, we're still going to use the same method, but if you look at this one, just like I said, you can decide to use either the row 1, right? Or you can use any row. But if you look here, in row 1, we have how many 0? 1, 0. In row 2, we have 1, 0. In row 3, we have 1, 0. But if you look at column 3, this column, you see you have how many zeros? We have 2 zeros. So since we have 2 zeros here, it's the best option to use. It will make our solution faster. So we're going to work with column 3. So how do we do that? The determinant, let's say this is our matrix A. The determinant is going to be, just take this 0 multiplied by the cofactor. Which position is this? This is first row, third column. So this is C13. Plus, then you start coming down because you are going by column. So this is 1. So you'll have 1 times C of what? This position now is what? Second row, third column. So you see that the column is not changing because the column is 3. Then plus, you go down, you meet this one. This is 0, so you have 0. Now you are going down, so you will have 3, 3. This is a position. Then plus the final one here, which is minus 2. So yeah, since it's minus, so you have minus 2. C of what? Which position is this? This is fourth row, third column, right? Okay. So now you see why this is easy, because of you have two zeros. It means this will go to zero and this will go. So you will have only two terms to worry. This is this. So you have just C23, right? And what? Minus 2C43. So you have only two terms. Then you proceed. You change it now to where? To minor. This is going to be minus 1 to power 5. Then what? M23 minus 2. Here you have minus 1 to power 7. Then what? M4 3. Is that? Now, this is going to be just minus 1, M23. Then here you will have what? This is minus 1. So this minus will become plus. So you have 2M43, right? So now we have to see now what is the minor in this case when you have a 3 by 3 matrix, right? So this now M23, what is M23? M23 means you delete what? The second row and what? Third column. So what is that? Second row and third column. So this one. And if you do that, you will have the determinant of minus 2, 1, 1, minus 3, then what? 1, then we have here 2, then we have 1, 0, and what? And 1. Is that okay? All right. Then plus 2. Now you have what? Here is 4, 3. So since it's 4, 3, what do? We delete this one. It means we have to delete the fourth row and third column in this case. So we're left with minus 2, minus 1, minus 2 and 1, and also 1, because remember this third column is deleted. So here we're still going to have 0, minus 2, and what? And 4, because the row 2 is no longer deleted, right? Then finally, remember what is column 3? Row 4 is also deleted, but row 3 is still remaining. So this one, which is minus 3, and what? 1 and 2. So this is what we have. Is that okay? So once we are here, you have two options. One option is to continue and reduce this again using the same method. Another option will be for you to, since we already know the Saros rule, which works for what? It works for the 3 by 3. Now since we have reduced it to 3 by 3, we can decide to just use the Saros rule, but that is optional. You can still go ahead. So let's try to see what I'm talking about. So since this is 3 by 3, you can decide to use Saros rule by copying this 2, because you want to find the determinant. So repeat minus 2, minus 3, 1, 1, 1, 0, right? Here also you do the same. You repeat minus 2, 0, and what? Minus 3, 1, minus 2, and 1. Then we draw our diagonal. So what will be the diagonal? This will be this going this, this one, right? And the main diagonal here also will be which one? This, and this one, right? Okay. So now let's draw the minor diagonals. This will go with this one. Yeah. Okay, so here we also have these diagonals. This going the minor diagonal. Yeah, this is going this way. This one, and like this. So here also you can see that these two are also free. All right, now we find the determinant here. So let's see. What is this one? Okay, I think this is one, not minus one. Yes. So if we look here, we want to find the determinant here. Remember, these are the positive ones. So this side, we will have minus 2 times 1 times 1. So this will just be minus 2 here. Then for this one, we'll have 1 times 2 times 1. So this will plus 2, right? Then the third one is 1 times 3 times 0, which is 0 here. Then minus, then this minor diagonal. This is 1 times 1 times 1. So this should be 1. Then 0 times 2 times minus 2 is 0. Then we have 1 times um, minus 3 times 1. So this is minus 3. All right. So remember, all of this, we have to multiply it with this negative. It's outside here. Then we do the same thing here. This is 2 into. Here now, we take this one to be the positive. So we'll have minus 2, and that is 4. So we'll have 8, right? Then here we'll have 1 times 4 times this, which will be minus 12. Then since we have a 0 here, this is going to be 1 times 0. So this is plus 0. Then minus the minor diagonal. So here is minus 3 times minus 2, which is 6 times 1. So we have 6. Then we have this, we have 1 times 4, which is 4 times minus 2. So that should be, I think, minus 8, right? All right. Yes. Then the third one is going to be 0 because we have 2 times 0 times 1. So this is 0 here, plus 0. So this is minus here. Inside here, minus 2 plus 2 is 0. So you have 0. And this is minus 2. There is a minus here. So this is 0 plus 2. Then plus 2. Here will be just what? 8 minus minus 12. So this will be what? This will be minus 4. And here we have 6 minus 8 is minus 2, but there is minus here, so this becomes plus 2, right? So here it will just be minus 2 plus 2 multiplied by minus 2. And everything will be minus 2 minus 4. So this will be minus 6. Minus 6. So this is the determinant. All right. Now, just a comment. If you look at this, when we got to this point here, remember we started from 4 by 4, right? Then we broke it down by using the third row because we had 2 zeros there. So we got to where 3 by 3 matrix, right? And we use the Saros rule. Now, if we don't want to use the Saros rule, you can decide to continue. What I'm saying is that let me use a different pen here. So what I mean is that when we got to this point, remember we got to this point, we got to determinant of A, it's minus M23 plus what? Plus 2M43. 2M43, okay? And we said this is equals to what? And we said that this is minus the what? The determinant of this 3 by 3 matrix, right? And now plus 2 of this one. Okay. Now, here we got to this point and we use the Saros rule, right? Now, if you don't want to use the Saros rule, what do? You continue again, just the same by expanding using the cofactor. So how can we do this? We can just say, okay, now this is minus, so here will be minus. Then you have a bracket. Then you look at here, you look at any row you like. You can use any row or use column. For example, we can decide to use row 3 because we have a 0 here, right? So if we do that, so this will be minus 1 times the cofactor. What is the cofactor here? This will be C31, right? Then plus 0 times what? C32 plus, remember we are going this way, then 1 times what? C33. Then plus, this is 2 brackets. Here, we can decide to use what? We can decide to use, this is 0 here, we can decide to use column 1, it's fine. If I use column 1, we will have minus 2, C what? C 1, 1, plus, now you use 0, C 2, 1, plus, finally, minus 3. So it's going to be minus here. So minus 3, C 3, 1. Okay. So now this is going to be, this minus is still out here. So you will change this to minor now. You change this to minor. This is 3 plus 1 is even. So since it's even, what will happen? Now, since it is even, sorry, here should be, here it's 1, not minus 1. Here is 1. Yeah. So this is 1 here. All right. So since it's even, what we have is, because we are using what we are using this row, right? Since it's even, you will have 1 times minus 1 to power 4, remember? Then M31. This one will go because you are multiplying by 0. So this one also will be 1 times minus 1 to power 6. Then M33 plus, this is 2 bracket, this is minus 2. You'll have minus 1 to power 2 times what? M11. This also will go. Then minus 3 minus 1 to power 4 times M31. All right, so we are going to have what? This is going to be just minus, this is just M31 plus what? M33 plus twice of minus 2 M11 minus 3 M31. This is what we have. So here you can break everything to matrix now. Remember, it's a bracket here. So what is M31? M31 means what? You delete the third row, first column. So this is this like this, third row, first column. So we are left with just 1, 1, 1, 2. Then plus M33 means you delete what? It's coming from this matrix, this matrix. So don't confuse this matrix and this one, right? So this is going to be, you delete this one and this. So we'll have just minus 2, 1, minus 3, and what? And 1. Okay, put a bracket, plus, here you have 2, and here what do we have? Minus 2. Here also we can change this to matrix. So M11, but look at the term. The term here is coming from where? It's coming from this matrix. So it means you delete the first row and the first column. And if you do that, we will get minus 2, 4, 1, and what? And 2. So you delete this first row, first column, first row. We're left with just this one. Then minus 3 into M31 will be 1, 1, minus 2, and what? And 4, because we will delete the third row and first column. Now we are almost done, so I think we need more space here. Let's see. All right. Okay. All right. So let's take this away from here. Now, all is left is just for us to do the algebra, and we are done. We'll get the same determinants with this method. All right. So if you look at this now, what is this one? You will see that this is minus. Here, what is the determinant here? The determinant here is just going to be 2 minus 1. So this is just 1. And what is the determinant here? Okay, let me just write it down. This is 2 minus 1 plus, this is going to be minus 2 plus 3, right? Because it's 2 by 2. But don't forget, you have a minus, and here you have 2. So here there is minus 2 outside, but the determinant here is what? Is minus 4, minus 4. Then we have a minus 3 outside, and here it's 4 plus what? Plus 2, right? So this is 1, so you have minus 1, so this will give you 1, and minus 2 plus 1 is also 1. Then plus 2, this we have minus 2 times what? You can see minus 4, this is minus 8. Then we have minus 3 times what? This is 6, right? So here, everything here, it's minus 2 plus twice of, here you have 16, right? So you have 16 here minus 18. So this will be minus 2 inside here. And here we'll have minus 2 minus what? 2 times this is minus 4. So this is minus 6. Now, this is the same answer we got earlier when we tried to use the Saros method after getting to the 3 by 3 matrix. So it's your choice. So if you have a 5 by 5 matrix, what do? You have to do it like twice. When you get to 3 by 3, then you use the Saros rule, or you continue until you get to 2 by 2, and you use the formula for the determinant for 2 by 2 matrix. All right. Then now the last thing here we want to see is how do we find the determinant of a matrix in triangular form. What do we mean? A matrix in triangular form. Uh, Triangular form, it means a matrix that is upper triangular or lower triangular. So this is very easy. As you can see now, example 7. Anytime you want to find a matrix, you say let A be a square matrix of order n, which is in triangular form. What do we need to do? We just need to multiply the elements in the main diagonal. We just need to multiply the elements in the main diagonal. So this is like a multiplication here. This is a multiplication. So this A1, A1, A22, A33, A44 up to ANN are the elements in the main diagonal. Because if you have a matrix, A11, A1 what? 2, A13, A14, dash dash up to what? A1N, right? Then here you will have A21, A22, A23 up towards A2N. Then if you continue, depending on the number of rows, we will have AN1, AN2, up to the last entry here, which will be ANN. So this element here these elements here, A11, A22, up to ANN, they are called the what? The elements in the main diagonal, right? Okay, now just let's look at example 7. It says find the determinant of this. So you are given a matrix. So you need to check, is the matrix in triangular form? Yes, this is in triangular form, because if you look at this matrix, where is the main diagonal? If you look at the main diagonal, right? So you see that below the main diagonal, every element is what? Every element is 0. You get it? Look at this element here. What do I mean by the element? We are looking at the element below the what? The main diagonal. So since the element is, all the elements below the main diagonal, they are what? They are 0, right? This is nothing but a what? This is what we call a, what type of triangular is this? This is going to be an upper triangular. So this is upper triangular, right? It's a triangular, but it is upper triangular, right? Because you see, every element below the main diagonal are 0. Only elements above the main diagonal are not 0. So you see these ones are not 0. So anytime you see this type of matrix, how do you find the determinant? Just multiply, just multiply the elements in the main diagonal. And what are the elements in the main diagonal? We have 2 multiplied by -2, multiplied by 6, multiplied by -5. That will give us the answer to this. Now, if we look at this one, if we look at this one, this is the main diagonal. Now, all the entry above the main diagonal are zeros. So this one is lower triangular. So if you want to find the determinant, it's simply what? Just multiply 3 times 3 times -2 times what? Times 2. That should give us the determinant. So anytime you have a triangular matrix, you are given a matrix, it's okay to check. Is it a triangular matrix? If it's a triangular matrix, just multiply the entry in the what? In the main diagonal. That should give us the determinant. So for example, now in this case, what will be the determinant of A? The determinant of A is just going to be what? B. Here we have, this one is what? 3 times 3. This will be 9 times what? Times -4. This is just what? -36, right? Then for this one, this is just going to be -4 times what? -5, which is going to be, okay, we can do times -5 times 60. This is just going to give us 20 times 60, which is 120. And we're done. So what is the summary here? If you are having when you are given a big matrix, first of all, check. If it is a triangular matrix, then just use this method. But you can still use the other method we discussed. It will still work, but this makes life easy and your calculation faster. All right, I hope everything is clear. If you have a question, you can put it in the comment section. Thank you for watching.